Hybrid Cloud Show, episode 33. I'm Aaron.
I'm Gary.
I'm Sean.
And I'm Shane.
Welcome to the show about public cloud, private cloud, and everything in between. Our views here are ours and not those of our employers. So something I don't think we have touched on that much so far, but I think is very important, is the idea of observability. Does someone want to give me a real high-level overview of what observability is and what it's trying to achieve?
Telemetry, metrics, tracing, all the buzzwords. Observability is the capacity to observe what is happening on your computers. And that's a very general thing because there's a lot to it. It's a very general concept. First of all, there are things like logging, which are log messages that come from your applications or your services or anything running on a computer. Then there are metrics, which are data points that can mean different things. For example, like CPU usage or RAM usage. How many times have I seen an error, right? All these things can be different metrics that are exposed, usually as some sort of number or value. And then there's tracing. And tracing is observing how services interact with each other, whether that's one service making an HTTP call to another, whether that's data flowing from one service to another. It can be a lot of different things. And so all three of these concepts kind of make up this general concept of observability. There's a lot to them, and there are a lot of providers out there. And I think it's definitely about time we get into the weeds of when to do what and why.
Well, I want to take a step back because you've kind of gone into a little bit of depth about different things that might make up an observability strategy. But if we want to talk about what observability actually is, it's really the capability to understand the current state of a system and deliver insights that you can action based on the current state of that system, right? So tracing, metrics, logs are all parts of an observability strategy. But I guess if you're not keeping your eye on what is going on in the system and what signals output and what normal looks like, then you don't have an observability strategy, really. You just have a bunch of tools.
So in the good old days, it used to be quite common to have something like, Nagios alerting set up to watch for key things you were worried about in a server. How does the more cloud-native style of observability differ from that, or do you still think that is an equal part of what you're doing there?
I think it's a part. Traditionally, you're right, we would have used something like Nagios or PRTG or one of these other platforms to monitor how many weblog errors are out there. Is the CPU at 100%? What's my memory look like? How much disk do I have free? And I think that is important, but I don't necessarily think that it gives us anything that translates to what our stakeholders in the business might actually need. So in the cloud world, what we generally look at is more things like business signals, so API response times, errors, transaction times, all of that kind of stuff. And if they're not normal, then we know that there's something wrong. And that might be that we dig into, is a server pinned on CPU, or does pod have enough resources assigned to it, or something like that. But in terms of the actual things that we're looking at and alerting on, generally in the cloud world, those are business metrics rather than actual infrastructure metrics.
Yeah, I think with the cloud, we've kind of abstracted to being closer to the business and less worried about the technical metrics on particular boxes. Like, while this might sound terrible, if you have, say, a memory leak that takes down a box every week, but it's in like a highly available multi-server load balance setup, maybe that's okay to live with for a while because it doesn't actually affect anything like business outcome. You should probably find out what's going on, but it's not necessarily maybe the highest priority. Whereas if it's kind of your servers are pets, not cattle, then that's a big problem.
It also seems that whole translation has meant a difference from a server raising an alert saying, hey, I'm not okay, to those metrics going off somewhere central and that central place saying, this thing doesn't look okay. Is that true, or am I imagining that?
No, I think that's true. I think if you think about something like an e-commerce site, right, what you actually care about is number of transactions that were successful. And if you see a number of transactions that are successful drop, or a number of carts abandoned suddenly increase, or a number of errors with your card processing provider increase, or a number of failed payments increase, I guess, in that case, then that's the sort of thing that you want to be looking at, right? It doesn't actually matter if the box that runs the cart processing is, like Shane said, at 90% memory. As long as carts are going through and people aren't just abandoning stuff, then that's probably fine, which is very counter to, I guess, a lot of the ways we'd have traditionally looked at this.
Another point to your question, Aaron, is how we approach observability is different. Usually you'd install like an agent on a box, right? And then that would report up. Or it would report itself, hey, I'm having an issue, right? It would send to a notification service. Whereas that whole entire concept, like you said, has changed. Now it's something is observing the whole stack, right? How all the things interact, whether that be CloudWatch or Datadog or Prometheus, whatever. And this observability stack is itself deciding there's an error here, or, oh, there's a tracing issue here, right? It's a fundamental shift from down up to up down.
And has that shift happened because we are now looking at more cloud native things that span multiple servers, or is there something else going on?
I would say take a step back from even thinking about it in terms of cloud native and servers, right? The way we architect applications and the way we interact with the business has fundamentally changed in the last 5-10 years. We've gone from 3-tier web application with some front end, some data processing and a DB, to lots of loosely coupled services with things like message queues and other stuff in between them. And that's a very different beast to look at and look after than a Postgres server sitting somewhere or something running PHP application. So I think that is one aspect of it. I guess the other aspect of it is that I think we've alluded to, we're all much more business driven now, right? The people that are going to be on our backs are not the CTO because a server has like 4 failed disks in it and he's walked into the data center and noticed. It's going to be the sales manager going, why have the number of orders dropped today? What's going on? We can see customers are accessing the site, but they're shouting at us because checking out is too slow.
I don't think I'm even getting alerts for like a Postgres database anymore. I just assume it's handled until there's like a real big problem, in which case then I track it down and I find, oh, it's my Postgres database. But no, if it's at 90% CPU usage, great, it's doing its job.
And I think having a box at 90% CPU usage now is much more acceptable than it was, right? That means that we've provisioned it correctly in terms of sizing and stuff for the most part. Whereas historically it was like, oh, we're going to need to go to Dell and buy a bigger machine for this because it's sitting at 90% CPU all the time. That doesn't matter now, right? Because we could just do a blue-green deployment or switch which one of our servers is the primary, increase the size of one, reboot that, fail back, increase the size of the other, and that could be done in a couple of hours after you've had dinner in the evening.
That's autoscaling 101. I mean, yeah, I don't provision 50, for like my storage or stuff. I don't provision a certain number. I just say go until I tell you to stop.
Well, and most cloud databases have storage auto provisioning at this point, right? Where that doesn't even become a problem until you see your bill at the end of the month and discover that your database has grown by 5 terabytes for some reason.
Yeah, that's the thing, I suppose. Those low-level metrics are kind of helpful, but not for observability perspective from things like autoscaling. Like if we know that the RAM's maxed out on a box or something else, maybe that means that we need to re-engineer something. But for now, it's just telling the autoscaler keep adding more resources to this. So it makes these kinds of events less critical and less of a knee-jerk emergency. The system around the box will keep this thing handled and managed if you set that up right. And then you can leisurely fix whatever memory leak or whatever later on during business hours rather than at 2 o'clock in the morning when your 2 servers are down and you need to ring Dell for a third.
So if it's about the architecture of the application, are there still legacy style applications out there? People who are installing more traditional applications sitting on a more traditional sort of server sitting there that you would then observe or monitor or alert on in a different way than you've been talking about here.
So I think there are still those like line of business applications that exist, right? I'm thinking about things like SAP is a good example of something that most businesses probably have and is sitting on a crusty server somewhere that they need to monitor. But I guess those are also applications that for a large part, cloud teams aren't looking after. The platform engineering team aren't running and looking after the SAP HANA cluster in most cases. For those, I suppose, they tend to be downstream dependencies of applications that we have, right? So in the case of SAP, maybe we're going and looking up customer records on there, or we're writing order records out to it so that if a customer complains, there's an order record that can be linked back to or something like that. So I think for me, I've never had to be so much concerned, or for a long time, I suppose, haven't had to be so much concerned about monitoring the health of that workload, but more the larger picture of how delayed writes to SAP or whatever it is might affect the overall workload that I've got. And then can I do things that are, I guess, just general cloud engineering best practice, right? Like exponential back off, retries, all that kind of stuff that we all know that we should be doing in terms of dealing with applications that don't scale well.
I'm interested because in my personal stuff, I tend to monitor it with the free Grafana account. And so I am using the sort of Prometheus style alerts where it pulls the metrics out of, ZFS or Sanoid or whatever and takes those metrics back to Grafana. And then I have my Prometheus style alerts set up there. But I did that primarily because I was interested in getting more familiar with all of that part of the stack. And I am pretty sure that you could achieve most of the same thing with the more traditional Nagios style alerts. And in honesty, I think sometimes in terms of the applications I've found, at least, the alerting side of the Grafana stack that I've found hasn't been particularly strong. I know there's things like ANAG you can use to monitor your alerts on Nagios stacks, where it comes straight through to the Android application and keeps bothering you. And whereas I haven't got something that is as good as that on the Grafana side, where it will keep working if my email goes down, for example. I mean, you always get into this classic kind of question of who watches the watchers whenever you're talking about observability, right? So you never want to have your observability stack failing in the same way as the rest of your infrastructure. But if it's coming through and it's the thing that's monitoring my email, and the only way I know about that is that my email stops coming after a while, that's not the ideal situation.
Let me ask you a question. When you set up your Prometheus Grafana stuff, are you doing that at the application level, or are you doing that at the infrastructure level?
Yeah, that's a good question. Most of it is more infrastructure based because it's things like, has ZFS reported that the pool is degraded? Or, is there a device that's got health issues that I need to go and deal with? Or is there a device that is physically too hot, as is the case right now in the UK, where my server sitting in my house has got so hot I had to turn it off? So, there's some of that in there as well. But yes, ideally things like my Jellyfin endpoint would be tested in there just as much as everything else. I struggle a bit with that because a lot of my infrastructure is set up behind a Nebula VPN. And so I could probably do that, but I would be doing it with something like text collectors on the nodes themselves, or I would have to find a way of getting Grafana, which is a hosted service, inside my Nebula network. So at the moment, I haven't been doing as much of that at an application level as I would have liked.
Yeah, I can see your point. Maybe you could have like a Prometheus server on-prem that would collect all your metrics from all your hosts, right? And then it would be allowed to send it up to the cloud.
Yeah, text collectors have worked pretty well, actually. You can do a text collector, write everything in Prometheus style. It's nice Python libraries, you can do that, and then you scrape them up again. So it's not impossible, but it's not as nice.
Yeah, I guess the way I'm doing this is slightly counter to your self-hosting the Prometheus and then pushing up to Grafana Cloud, because I'm using net data for a lot of this stuff where I have the agent on the machines and it collects all of those metrics about CPU, IO weight, memory, but also Docker health checks it monitors. So I have the Docker health checks set up for all of the applications sufficiently so that if they fail, net data will alert me. And then I sort of work it out that way. And then for stuff that's external facing, I've then got Uptime Robot just pinging those and doing an HTTP head on them. And that generally is sufficient for most of the things that I need. But again, it's sort of outsourcing the problem to someone else so that the person watching the watchers isn't also the person maintaining the infrastructure.
Layered approach, always a practical strategy when dealing with this kind of stuff. I also self-host my own Prometheus cluster where I have Alloy getting all the metrics and then sending it off to a Prometheus server, and then the Prometheus server can hit a webhook if it needs to. So I have all that self-hosted, it's all local, but at the same time, I also use Uptime Kuma. And so if anything ever happens publicly, then I'll know about it. And it actually even works for my internal sites too, because it's located at the other side of a WireGuard connection.
Nice. To maybe pull us back from the self-hosting angle, the question I had was about like designing good observability systems and not just tell me when things have broken, but also like when there's an incident in a company and you're doing a post-mortem or incident management process, like how do you know you've got all the data you need to tell the story of what's happened when something goes awry? Is there any lessons anyone learned that like, hey, I actually should have been collecting something completely different to what I originally intended to try tell the story of what's happening in these systems?
Tracing is the most critical thing that I've ever seen. It's relatively new as far as me implementing it into my applications, but it has been a game changer, especially some of them that can do like live JVM profiling. Like that's just a total game changer. But it's always after the fact when I needed those traces that they don't exist. And I'm like, should have worked on that backlog ticket. So tracing is one of those things that should be enabled on all services by default. And that way you can have your spans all correlate with each other. And then that will get you the insight you need, especially for something like a postmortem.
Absolutely agree with that one. It kind of speaks to the whole conversation we're having that like I've seen in situations where there's been really gnarly, hard to trace bugs that have been livable with. But as time passes and things scale, that becomes a really big problem. And having full stack traces of exactly where everything's being executed with like a traceable ID across systems has been absolutely essential for like figuring out what the hell's going on and actually fixing the thing you've been ignoring for like 6 months.
Yeah, that kind of real user management, I think, is super key, right? Is monitoring an actual user's request and the way that it goes through the system, what it touches, having a trace ID that you can actually correlate from it hit my load balancer to something was committed to a database is really, really important. I think the other thing that I've always found really useful is that synthetic monitoring, as opposed to just having real user monitoring, where you've got something running a known request through your platform at any one time, and you can easily identify those. And then you have a canary request that you can just say, hey, something went wrong with this. Go tell someone. And that is a little bit more difficult to set up because obviously you need to work out how you identify that data, how you make sure that that's not having a huge performance impact on the actual system, but is also really useful in environments where perhaps you can't go and look at customer data, right? Perhaps you're a bank or some kind of other regulated industry. Having a synthetic request that's hitting production that you know is safe, that you can touch and you can use for troubleshooting is often something that I quite like doing too.
You talked about having a user query going through in a traceable way. How in practice is that happening? Where's that user ID being encoded in the various places it needs to be to make that go through with a trace that you can look at?
So I've generally outsourced this to one of the cloud provider services. So AWS has a service called CloudWatch Run, which effectively does this for you for the most part. So I don't know how exactly I would go about implementing it, but there are certainly services out there that help with this stuff.
So if you're going to do this on your own, which I recommend you use a service for this, stuff like New Relic and Datadog are pricey, but they're there for a reason. It's because they offer all the services we've talked about. They offer the tracing, they offer the synthetic monitoring, they offer the real user time management. That kind of correlation is tough to do yourself. And I think for me, my personal experience, getting that functionality out of a service is worth the money you're going to put in. But usually what happens is every single request on every layer comes with this thing called a span or a span ID. And the trick is, how does a click over here on this UI correspond to a transaction in a database? And that whole process is called correlation. And so at a very high level, you have to track those IDs of this span went from this service to this service, and this is its ID. And then it did this thing, right? And then you have a span from my user to click, and then from click to backend, and then from backend to database. And that's how you correlate all these different things together. And that's not easy to achieve if you're just trying to spin it up on your own, especially something like real user time management. But it is absolutely critical where you can see, like, for example, in Datadog, you can see visibly an HTML page where a user clicked, you can see them click, and you can see exactly from there, okay, now show me this trace on the back end, right? How long did this take? How many Postgres queries did I have to make to process this backend call? And then you can break it down into each one of those queries and run performance analysis on each one of those queries to see, oh, this first one is looking for an index that doesn't exist. That's a very high level overview, and it kind of goes into the detail of why this is so powerful.
Yeah, I think that's exactly what I was trying to say, Sean. It's have a service which is going to do this for you, because implementing that stuff on your own and scaffolding it is essentially impossible for a team that is like a normal size and a normal organization. If you can just go and put in CloudWatch RUM or Datadog or Tempo or one of the other services that integrates nicely with the platform tooling that you use and just gives you this stuff out of the box, then that's the thing to do.
Are there open source tools that do it, though? Tempo's open source, isn't it?
Yeah.
Tempo is part of the Grafana stack that does the tracing aspect of it. Then there's Loki, which does the logging. And then there's Prometheus, or what's the other one? Cortex, yeah, for the metrics, right? Those three pillars of observability like we talked about. And then Grafana is like the UI that kind of binds them all together. So that's the open source version. Another thing I want to call out is the open source instrumentation. That's a new word here. Instrumentation is the libraries that you use in your applications to export this telemetry. And there is a very famous one called OpenTelemetry. Sometimes it's abbreviated as OTel. And that is what I try to get all of my developers to use when they build their applications. But there are downsides. For example, if you're trying to use like OpenTelemetry with another service like Datadog or New Relic, then you have to add custom tags basically to all the data you're sending to them. That way they're able to parse it and correlate it and make it show up as it would natively if you were using like the Datadog agent.
I guess not in their interest to support open standards, right?
I mean, they support it. You can do it, but it's not going to show up as nicely.
So I think the part I wanted to touch on as part of your question, Aaron, is what do you do after you've done this stuff? Like, how do you run a retrospective? How do you improve this stuff? Because it's all very well having your observability stack set up to tell you ahead of time that this thing is going to happen, et cetera, but how do you go about that continual improvement process? And how do you run retrospectives that don't just make engineers think that they're going to get in trouble because they wrote the bad SQL query, or they didn't set the timeout correctly on the load balancer, or whatever it is?
Yeah, intuitively, it feels like this is going to be slightly easier than it would be if you were using the more traditional approaches, because at least you have time series data on a lot of the stuff that in theory should be relevant, right?
Yeah, I mean, in my mind, I think there are probably 4 or 5 things that you've got to discover, and then you work out how you action those things to make sure that they don't happen again, or why they happened and how someone got in a position of taking a certain action, or how a system got in a position that that was a thing that could happen. And I think for me, those are like, what actions did someone take or did a system take, and when? What effects did those actions have on the overall health of that system, and why? What did we expect to happen when that action was taken? And the assumptions that we made that maybe didn't document about the health of the system. Like, did we think that 500 milliseconds to get from one part of the system to another was okay? And I think if you can establish those things and keep it incredibly factual, what you have is then a very simple set of actions from the retrospective of, okay, well, why was that action taken? Why was that effect observed? The expectations we had, were they correct? Were they incorrect? How do we need to change the way that we think about that? And then if there were assumptions we made, why were they incorrect? And what do we need to do in order to make sure that we're making more accurate assumptions, or making assumptions that perhaps we shouldn't be making in the future.
I'd argue you make no assumptions at all. But you're right. Absolutely. That kills us every time. I've seen it so often where someone set an alert for a threshold of like an hour. So it was an hour until somebody was notified of something, when in reality, it should have been a minute. But an assumption was made.
I've seen some of these tools starting to integrate, air quotes, AI in the incident process, or even in the process of trying to predict failures in the future. But it looks nice in the UI that you click start an incident or something, and then it comes up with a summary of the things that look a little bit different than normal in what might have happened. Has anybody used those yet or seen value in those things?
I have, only in limited amounts, not so much for incident, but for predictive failure analysis. And I'm pleasantly surprised. It's not looking at critical, what are called KPIs, key performance indicators, that I'd like it to out of the box without me having to configure them like I do normally for my alerts. But, you know, it'll look and say like, oh, there's an increasing number of 500 errors that shouldn't happen. I should probably throw an alert. And that's just one monitor you can set on, or one alert you can just set on your service that can kind of act like a catch-all as like a default. And a lot of times if you add a new service to one of these observability tools, it'll kind of give you to you by default. But outside of kind of just being like a basic catch-all, not really impressive.
The challenge you've got is context. Even ignoring AI, sometimes trying to figure out what's gone wrong can be a bit of a detective hunt. So it's like this thing that happened several systems away. Someone uploaded something that was slightly different to before, and now that's hit a limit in a system several systems away that's not been using gzip encryption or something, and so something's blown up essentially. And knowing to provide the AI that context is very hard to do without having experienced the incident, if you know what I mean. And then you'd solve the problem rather than maybe providing adequate reporting, because that might be something that's very rare to happen. So it's like you can't give the AI too much context because it just has a limited context window, and it can't go interrogating and feeling around. It can't go talk to people as well. Like it's very limited in scope, particularly as we talk about like we're reasoning about single systems or even small systems, business outcomes, which can be a whole plethora of systems behind it. So it makes it hard actually to solve this type of problem, I think. But for predictive analysis, I think Sean's right. Like that sort of stuff where it's kind of here's the baseline, compare some well-defined metrics against that baseline. It could help, but I would be worried about AI right now in this space.
Yeah, this all falls under that AI ops umbrella, or what we would have called MLOps before AI became the new buzzword, right? I guess there are a few aspects to it, right? There's the pattern detection bit, which I guess is what you were talking about, Sean, right? Which is this system usually produces 500 errors an hour, and I now know that it's producing 500 errors an hour. Probably go tell someone. So that, I guess, is one thing. And we know that, like, we've all got crap tons of observability data sitting around somewhere, right? Like, my Prometheus database was absolutely huge when I used to run Prometheus on-prem. Like, I had probably a year or more's worth of data on my applications, which is far too much. But what it would have meant is that if I'd given one of these AI ops pattern recognition tools access to that, it would have had a very good idea of what was normal and would have been able to pick out that needle in a haystack of, hey, for the last year, your system has been X, and now it's X plus 1. You probably want to look at that. Then there's, I guess, the part that you were talking about, Shane, which is the inference of what has gone wrong. And I think that's probably the weakest area of those AI ops tools at the moment. It doesn't have the context, right? And I have yet to see one of these AI ops tools that could look through Confluence and get all of my historic reports and actually make an accurate thing on that. But I guess the one that is actually fairly useful is the automation bit, which neither of you touched on, where we can say, hey, I can see that your number of requests queued in your message queue is growing. I know the consumer of this message queue is this system over here. perhaps I should go and send a command to the AWS control plane to auto-scale the consumer of that queue because I can see the queue is growing. That's the kind of thing that it probably is quite useful for. But again, you've got to have a lot of trust in whatever is running that automation, not to just go, the queue is 1 million and go and scale up the stuff in the back end really quickly, when actually maybe you're just doing a bulk ingest and maybe it's not a FIFO queue and you don't care because it's not going to impact production and it can just kind of sit there and do it in the background.
That's pretty cool. I've looked into that.
Yeah, like that I think ultimately is where this stuff is going, but it's got to be right.
Tightly scoped, metrics driven probably is the safe place to put it with constraints.
I mean, I can also see some benefit in theory of it in an incident where everyone's trying to figure out what's gone wrong and everybody's yelling at you. That, it's great to have all this data, but finding the ideological needle in a haystack is quite hard. So I can see that if it can get rid of the manual toil of reviewing all of those logs and at least giving you a shorter list of things to review, there's scope for improvement from it. But yeah, proof is in the pudding, right?
Well, yeah, until the first time you run an incident with it and it sends you down a complete rabbit warren that means that you end up taking 5 hours to resolve the incident rather than 1.
Or confidently states a load of rubbish that sounds convincing and you operate off those assumptions and, learn later on.
What do you mean that my flux capacitor is too backed up?
Well, that's a logical place for us to wrap things up. But before we do, just a quick thank you to our existing PayPal supporters and patrons. If you'd like to join those people, you can at hybridcloudshow.com/support, where for various amounts on Patreon, you can get an ad-free feed of either just this show or all of the Late Night Linux family shows. And sometimes we release episodes early. If you have any questions or feedback, please feel free to send those in to show@hybridcloudshow.com. We'll be back in 2 weeks. Until then, I've been Aaron.
I've been Gary.
I've been Sean.
And I've been Shane.
See you later.